Hi everyone, welcome back to my YouTube channel Tech Data Engineer. So in this video we will see what is LangChain and how you can build the applications through LangChain. Okay, so in this video we will see LangChain in details like how you can leverage LLM, how you can leverage tools, and how you will build AI agents from LLM. Okay. So before building your first agent, we need to understand the LangChain in detailed way so that you can leverage, you can know understand all the functionality, what are the features, what types of enterprise applications you can build through LangChain, or if it is not, then what is the disadvantage of LangChain, why we are going with LangGraph or OpenGPT or different auto GPT. So whatever the different what are the different way we have to build the AI agents, we will see in this video. Okay. So from very basic we will understand what is LangChain basically. Okay. So hope we have already like uh, we have already familiar with this LangChain terminology. Okay. So LangChain is basically it is a open source framework, right? So for UI, for orchestrations we have different framework, right? For Android we have the Android framework. For Flutter applications we have different framework. Similar to that, for any LLM based applications we have this LangChain. Okay. So why LangChain? What problem LangChain did solve and all? We will see. Okay. So LangChain is a open source framework basically. It is basically a open source. So I'll write the definitions also, right? So it is a open source framework, right? Okay. So if I'll write the definition here, it is an open source framework. Okay. It is basically an open source framework for building building application application based on LLM. Okay. So this is the simple definition of LangChain. It is an open source framework for building application based on LLM. Okay. So this is the examples of this is the simple definitions of a LangChain. Okay. Now we will see what problem does it solve. Okay. So now we understand like what problem what is LangChain. Okay, so now we will see what problem it solve, what is the core architecture of LangChain, what is the main component, and how it works internally. Okay, and when to use LangChain and when to use LangGraph or other framework. Okay, so suppose let us consider a scenario, right? So what problem does LangChain solve? Okay, you'll see in this so suppose there is a LLM, okay? LLM, okay? This is one LLM and there is a user, okay? User. So what user giving prompts, right? So whenever user giving prompts to LLM, what LLM will return? It returns the response, okay? Response, okay? That is text base or anything, okay? It's like a text output we have, okay? So a raw LLM is like we have GPT, we have Gemini, we have Vertex AI and all. Okay. So whenever as a user we are giving prompt to LLM, it is returning the response as a text output, right? So we have user, we have prompt, we have LLM and text output. That's it, right? So there is no other concept in this case. But if you'll build some real world AI application, right? So but if you'll build some real world AI application, okay, so whenever you build real world application na, so you need something. So what you need first you need the memory. Okay, first you need the memory. Second you need database access. Okay, database access for RAG related things. Then we need API calling. API calling. Okay. Then what we need tool uses. Okay. What are the work you wanted to do through LLM through agents? Okay. Then we need multi-step reasoning. Okay. Then what we need? We need document retrieval in case of augmented RAG. Okay. Retrieval augmented generation. So document, we need document retrieval and then logging. Okay. So whenever you are building the application, we need all these things. Okay. So if you build all that manually, so there are two way, right? One, you can build all this like memory related things, data access. You can build different microservices, tools, and different microservices, and you want your LLM to access all these things whenever they need, right? So if you build all that manually, it becomes messy and too complex. Okay. So what is the issue? If you build manually, it will become messy. And then second thing is complex. Okay. Complex, time consuming. Okay. Time consuming. Everything is there if you build it manually, each and every component. So for these types of problem, LangChain comes into picture. So LangChain provide a structural framework. Okay. So LangChain, it provides a, a structural a structural framework. Okay. It provides a structural framework to combine. So what is combine? LLM plus tools plus memory plus retrieval plus control logic. Okay. Plus control logic. Okay. So it provides all these things: LLM, tools, memory, retrieval, and control logic. Okay. That provides everything into a single application, and they provide everything in that bundle that is called LLM framework. Sorry, that is called LangChain framework. Okay. That is called LangChain framework. Okay. Basically. Okay. So think it like it's like a Spring Boot for AI apps, okay? Or you can say Django for LLM or Airflow for AI system, okay? So a Spring Boot for AI apps, or you can say so everything you can consider as a LangChain, okay? A Spring Boot for AI, Django for LLM for calling the API, Airflow for orchestration, and what a Spring Boot does, does this microservices things, okay? So like problem it solves. So we understand what is LangChain, then we understand what problem LangChain does solve. Okay. Now we will see high level architecture of LangChain. Okay. So if you'll see high level architecture. Okay. So if you'll see high level architecture, what is that? So first is the user input. Okay. User input. Then we have prompt. So prompts template. So in normal LLM, raw LLM, we are giving prompts by our own. But in case of LangChain, we have the templates for every prompt so that you will get the correct answer. So that is the benefit. Prompt templates. Then we have LLM. Okay. So in LLM, you can solve. So these all are the optional. Okay. Optional means you can use tools if you want. If you don't want, you can't use. Then we have the tools, we have memory, then we have vector, vector store, like vector database we can consider. Then we have the agents, okay, agents, okay, and then it gives the after agents, then it gives the final output, okay, final output, okay. So LangChain acts as a glue between all these pieces. Okay, so user, prompt templates, LLM tools, memory factor, everything is attached by this glue. Okay, so LangChain act as a glue between all these pieces. Okay, so we understand the overall high level architecture also. Okay, so now we will see components of LangChain. So what are the things in LangChain? Okay, components of LangChain. Okay, components of LangChain. Okay, so first is LLM. So we already know LLM is the brain of basically LangChain. So LangChain supports multi LLM providers. Multi LLMs means we have OpenAI, we have we have Google GCP, Google Cloud Platform. Then we have and under Google Cloud Platform we have Vertex AI or we have Gemini. Okay, so everything is provided by LangChain. Okay, so LangChain does not create model, right? So it only connects to them. The first is the LLM. So how to connect to? So if you wanted to connect to any models, how will connect? You can connect like you can create a variable LLM equals to Chat GPT, Chat OpenAI, Chat OpenAI, and then you'll pass the model like model equals to whatever you want, like GPT 4.0 mini. So you can pass like that. Okay, so it will connect. Or suppose you wanted some other, so you can pass like Google. So you wanted to connect GCP. How will connect? LLM equals to Chat Vertex. Okay, Chat Vertex I, Vertex AI. Okay, Chat Vertex AI. Then you can pass like a model. You can pass the temperature also. Model equals to whatever the Gemini, something like that, 1.5 and all. So you can pass like that. So this way you will connect your LLM through your LangChain. Okay. Then second is the prompts. Second component is the prompt. So we already know what is prompts and all. Okay. What is prompts and all. Okay. So instead of writing messy things, it has the structure. So but the benefit is that so whatever the LangChain is providing, that is called a structural prompt. Okay. That is a structural input. That is a structural input and prompts. Okay. So instead of writing the messy string, LangChain provides prompt templates. Okay, so how we'll do that? I'll see in the different. I'll see. I'll use prompt. So you can write like something like that. So you need to import from LangChain. I'll explain in the VS Code also. From LangChains dot prompt import prompt template. If you'll do like that, prompt template. If you'll do like that, you are able to import the prompt. Then you will write gives variable prompt equals to prompt template, prompt template. Then you can pass input variable equals to whatever the topic you want, like topic, and then you can pass the template. You can pass the template like whatever the explain. You can write like that explain. Suppose input variable is topic, so explain. Then we will pass like a whatever the topic you want. Okay, so topic will pass as a variable and in simple terms. So if you'll do like that, you don't have to write the prompt. So whatever the topic will provide, it automatically give the explain something like weather in simple terms. You can do like that. Okay, so this way you can use temp prompts. Okay, so why this is beneficial? Because it gives the clear structure, reusable prompts or dynamic variable. But so instead of topic, instead of whether you want something different thing, you can give as a topic. Okay, so that's the better control. Okay. Now other things we have like a third things is like a chain. Okay. So what is chain basically? Chain is a so so long chain is basically about chain. So chain is like a multiple steps combined. So what is chain? In case of lang chain, it is basically a multiple steps combined. Okay. So you can combine multiple steps like pipeline. Okay. So but this so if you but this agentic the modern LangChain, if you know, modern LangChain is basically more like a agent focused. Okay, agent focused instead of chain. Then fourth thing is like tools we have tools. So if we'll understand each and everything, we are very means we will understand how to build agents and when we require tools, when we require chains and all these things. So tools is nothing like it is like a Python function. So whenever we are writing anything, like if I'm writing as I'm building agent to count some rows of a table, right? So what I'll give the table name and for that we need to define a function to count the number of rows in a table. So that is called basically a tool. So tools in a LangChain is basically a Python function that agent can call. Okay, so this is basically a Python function. Okay, Python function that agent can call. Okay, agent can call. Okay, so this is basically a Python function. So how will you'll define a tool in LangChain? So you'll write like something like at the rate tools. How will defining the decorator? So you can define like at the rate tool. Then we'll create a function like diff. Diff is defining like suppose like a uh, check row count. Suppose like that you wanted to define a function check row counts. Then you will pass like a table as a string. What is the return type? That is also string, and then it you will return like a function like a return row count is xyz. Okay, so something like that you can define a function. Define first we will write like decorator at the rate tools. Okay, then it is indicating that this is basically a tool, and then you're writing that Python function define check row count. We'll passing the table as a string and we're getting as a string, and then returning row count is a xyz when any numbers. So that is the tool. So this way we will define the tool. So tools you can define for anything. So if you want to query database, we can define a tool, query database. Then for call API, you can define your tool. For running any Python related things, you can define a tool. For checking logs, you can define. So whatever the activity you wanted to do, whatever the activity you want your agent to complete it, what you have to do, you have to define a function in Python that is called tool. So you can define multiple tools to whenever you required in your uh, whenever you're building the agents. Okay, so this is what it makes more powerful like agents. Okay, then fifth you have the agents. Agents is also the component of LangChain. So agent is basically a decision engine. Okay, it takes the decision, basically a decision engine. Okay, so this is the most powerful concept. So what is agent basically? So I have already explained in my previous video. So agent equals to what is agent? So agent is nothing but it is a LLM plus tools plus decision loop. Okay, plus decision loop. Okay, so we already know what is LLM, what is tools. We understand what is decision loop. Okay, so it can think. So what agents can do, it can think, it can choose tools, it can execute and observe, and then it returns the final answer. Okay. So agent basically follow the React pattern. Okay. A React pattern. We already know this terminology. What is React pattern? So React pattern is basically a so instead of prompt and giving the answer, like a normal LLM, what it does is basically it set the goal first. Okay, then what it will do, it will reason. Then what it will do, it will act. Then what it will do, it will observe. Then what it will do, it will repeat and give the answer. Okay, give the answer. So these are the steps it is following. This agent is following. Okay, so this makes it more agentic. Okay, so agentic thing. Then we have the sixth component is like a memory. So why memory is required in LangChain? So LLM do not remember the past messages unless you provide the memory, right? So if you have already seen sometimes whenever you are answering question, you are asking Chat GPT. So based on your previous conversation, it is giving you the answer. So that's why memory is must required. Okay. So LangChain memory model help to store chat. So if in case of here LangChain, so LangChain memory model helps. First, how it helps to store chat history. Then second thing, summarize previous conversation. Summarize previous conversation, whatever we have done. Then third thing, retrieving relevant context. So in all this case, it is required. Okay. So conversational, so we have like a summary memory or conversational buffer memory. So without memory, agent forget the context in which context you are asking the answer. Okay, so suppose you are talking about the Delhi or some different city, and then you ask the weather. So if it know, okay, like you are talking about the Delhi, and also it will give the weather of Delhi. But if you don't know the context, you don't have the memory feature, it will like give the biased answer, or it will not give the proper answer in which context you are asking the temperature and all. Okay, so that's why memory is required. Now seventh is, the next is, we have vector store. Okay, that is RAG system. Vector stores, basically a RAG system. So we already know, I have already explained what is RAG, retrieval augmented generation. So if you wanted to train your model on top of LLM plus your own database, or you can say your context of information you wanted to training, that is called retrieval augmented generation. So for document based question and answer, LangChain support vector database. So it supports database like Chroma. Then we have the Pinecone. Okay, Pinecone. So retrieval augmented generation, basically, if you have user questions, so convert to embedding, then search the vector DB, then retrieve the related document and send it to the LLM. Okay, so these are the components of our LangChain. Okay, now we need to see how LangChain works internally. Okay, so suppose, so how LangChain work? I'm asking like how LangChain works. So internally, how LangChain works? So suppose I'm a user, okay? I am a user, I'm asking a question, analyze. So I'm building something agent, okay? Agent so that it will solve this problem. So analyze big query cost, inefficiency. Okay, so BigQuery, what is that? Sometimes cost is too much high due to some certain reason, right? So if I wanted to build some agent, if I wanted to build some agent, so what will be the approach? Okay, so we will see in this concepts. Okay, so suppose user asks, analyze BigQuery cost inefficiency, and they are building a agent. So how internally it will happen? First step is like LLM receive the LLM receive goal. So what is goal? We need to analyze the inefficiency cost in LLM. Sorry, in BigQuery. So LLM receives the goal. Then what it will do? It regions. Okay, it regions. What LLM need? Like it need billing info. Like what is the billing and all these things. So it required. Before that, it can't do anything. Then what it will do? It select tools. So how it will select? So what tool it needs to select? So it already know it need the billing info. So for billing info, it required the check. So we have already told like check billing spike. So we have already a Python function which is giving the billing spike. So it will check this function. This is called tool. What is the next step? it will execute the tool. Tool executes. Then what is the next step we have? It observation return. So whatever the observation it has, it will return. Okay, observe observation return. Okay, observation return. Then what is the next step? So after observation return, LLM region again. Okay, then it choose the next choose next tool. Okay, based on the LLM region, it will choose the next tool. Okay, which tool to use. Then it will give the final answer. Until and unless it is not giving the correct answer, it is reasoning and acting. So that is called, it is based, agents are based on the React framework. Okay, the final answer generated this way. Okay, so this way basically our LangChain basically works, or you can say this way we are building the agents. Okay, agents. Okay, so LangChain is managing everything like tool registration, executions loop, message forwarding, error handling, and injection. Everything is managed by LangChain only. Okay. So now in this video, I have already built agents. We will see like end to end. So I have already taken the use case, right? So here I have taken the use case, analyze BigQuery cost inefficiency. So I'll explain how I have built, and I'll see how so after deploying also I'll showcase like what is the result and all. So overview I'll see. So we have the problem like we have the problem like GCP cost monitoring AI agent. Okay, so this is basically our GCP cost monitoring this agent. Okay, so first what we need like BigQuery expense. So we know BigQuery is expensive query, this billing spike or suggestion optimization. So whatever the query that are running in the BigQuery, and if that is expensive, it will give agent will give as a things like this query is expensive, it will give the billing spike. So if your limited if your billing capacity is whatever the billing threshold you have, if it is reaching that, it will give the billing spike, and it will give the suggest optimizations also, like which query to use, what are the solutions we have, right? So for that I have built some agents. So what are the so how what is the step we have to do? I'll explain that also. And this is basically production style things. Okay, so what agent will do? So the agent will, this will check the last 24 hours BigQuery jobs, that detects the high GB scanned query, and detects billing spike and recommendation or recommend optimization. So if you'll see the structure, I have not given the structure because if I'll commit the code, I'll explain the structure also. So if you'll see, the structure is like we have the GCP cost agent, okay. Then we have the app.py which for running the application. Then we have the tools. Tools, there are two tools. One is the BigQuery tools and one is the billing tools. BigQuery tools is go, it will check the all the queries and related to BigQuery, and billing tools is basically for spiking. Then we have the requirement.txt or readme. These are the folder structure we have. Okay, so first step is to set up the GCP. Okay, because we are working in GCP, so what we have to do? We have to enable the API like Vertex CI API or BigQuery API or Cloud Billing API. Okay, then what we will do? We will export the Google Cloud application platform, and we will give the path of service account.json. We are expecting the key and we are exporting. Okay, then what we have to do? Second step we have to do, we have to install the dependencies. So what is the dependency we have? Like pip install LangChain, and from LangChain we are importing the Google Vertex AI. Okay, and then we are things also from Google Cloud BigQuery. We are things Google Cloud Billing. Okay, Google Cloud BigQuery and Google Cloud Billing. Okay, these two things we are importing. Then next step is to create BigQuery tool. Okay, then from LangChain tools we are importing the tools, and from Google Cloud import we are importing the BigQuery. We are we are writing the we are I can say initiating the clients, BigQuery.clients. Then we are writing the tool. Tool is basically to check the expensive query. It will go, it will check this expensive query. It will give the result here, and then output is here. So this is the one basically tool for checking the expensive query. This is the other tool. This tool what it will do? It will check the billing spike. It will go. It will call the a billing API, and it will check basically. Okay, then what is the other step? So this is for creating the BigQuery tool. Okay, so first is BigQuery tool, other is the billing tool. Okay, then we have the then we have finally we have the main. So main app. This is basically main app. So langchain.google vertex import chat vertex AI. This is for this is basically we are calling the API initializing LLM vertex AI Gemini. Then we are calling the tool. There are two tools I have already explained, right? Check expensive query and check billing spike, and based on that we are writing the agents. Okay, so this is basically our main application. And then what it will do, it will give the, we are running the python.app.py, and here agent.py. So what we will write, will agent.py. Okay, basically we are running python agent.py. So this way we will run that. So what happens internally? So whenever user gives like a analyze GCP BigQuery efficiency, so what it will do, the thought is it will go, it will check the billing trends. Then what is the actions? Check billing spike, then check heavy query. So for that it will go, it will choose the query related tool. Then observation, so large scans detected, right? So final answer is like partition stable, and then it will give the observation like partition stable or avoid select or huge clustering, and review all these things. So this way you can basically build some agents, and you can mm, build some agent to get all these details. Okay, now coming to the deployment. So how you will deploy? If you wanted to deploy, I'll show you also. So you can deploy on Cloud Run, or you can deploy it on GK directly, or you can run daily by Cloud Scheduler or PubSub. Okay, so this way you can do that. And then you can, if you are making some enterprise level, you can upgrade to the enterprise version by adding some alert related, so Slack alert or some other mail alert, everything you can add it here. Okay, so once I'll deploy it, I'll showcase these agents also. Okay, so for now, that's it. We understand what is LangChain architecture, how to build the agents through LangChain. Okay, thank you, thanks for watching.